In today's problem, we have cobalt-2 chloride reacting with potassium phosphate to form potassium chloride and cobalt-2 phosphate. Calculate how many grams of potassium chloride can be produced from 125.0 grams of cobalt-2 chloride. We'll start by writing the unbalanced equation. We'll start with cobalt-2 chloride. Cobalt-2 is a variably charged metal with a charge of +2. So we'll start by writing cobalt. Chlorine has a charge of -1. So we'll write this as CoCl2. We know that because the charges have to add to 0, cobalt in this case has a charge of +2, and chlorine has a charge of -1, but we have two chlorines. So when we add those together, we've got 2 plus -2 equaling 0. Next, we write potassium phosphate. Potassium, written as K, has a charge of +1, and phosphate is written as PO4 and has a charge of 3-. In this case, we'll need 3 potassiums to 1 phosphate. On the right-hand side of the equation, we have potassium chloride. Potassium is written as K with a charge of +1, and chlorine is written as Cl with a charge of -1. 1 plus -1 adds to 0. Lastly, we have cobalt-2 phosphate. Again, cobalt is a variably charged metal with a charge of +2, and phosphate is a polyatomic ion with a charge of 3-. In this case, we'll have 3 cobalts to 2 phosphates. Next, we'll write the balanced equation. To start, we'll write our unbalanced equation. So we have cobalt-2 chloride reacting with potassium phosphate, forming potassium chloride and cobalt-2 phosphate. Next, we'll add our coefficients. We'll start by balancing our phosphates. On the right-hand side of the equation, you can see that we have 2 phosphates, so we'll add a coefficient of 2 on the left-hand side. That changes the amount of potassium that we have to 6, so we'll add a coefficient of 6 on the right-hand side. That then changes the amount of chlorines that we have to 6, so we'll write a coefficient of 3 on the left-hand side, which also balances our cobalts. The question is asking us to calculate how many grams of potassium chloride can be produced from 125.0 grams of cobalt-2 chloride. We'll start by writing 125.0 grams of cobalt-2 chloride. Next, we need to convert this into moles to get our mole ratio. We do this by multiplying it by 1 mole over the formula mass of cobalt-2 chloride. The way that we get the formula mass of cobalt-2 chloride is by adding up the individual formula masses of the individual elements. So for cobalt-2 chloride, cobalt weighs 58.933 grams. Chlorine has a weight of 35.45. And we have two of those, so we're going to multiply those by 2. We're going to add these together. To get 129.833 grams of cobalt-2 chloride. You now need to multiply by the mole ratio. The mole ratio is always written as the given on the denominator and what you're looking for in the numerator. In this case, we're given our 1 mole of cobalt-2 chloride. And we're looking for potassium, and we're looking for cobalt-2, we're looking for potassium chloride. When we go to our balanced equation, potassium chloride has a ratio of 6:1 moles. We now have the mole ratio, and now we need to turn our moles into grams. So we're going to multiply this by the formula mass of potassium chloride over 1 mole of potassium chloride. To get the mass of potassium chloride, we get our mass of individual of potassium, which is 39.098. And we get our mass of chlorine, which is 35.45. We add them together to get 74.548 grams potassium chloride. Altogether, we get 143.5 grams of potassium chloride being formed from 125 grams of cobalt-2 chloride. Now, when checking for sig figs, we're going to be looking at 125.0 as having 4 significant figures, and that will inform how many significant figures we have in our problem. As we can see, I've written 4 significant figures here, the 1, the 4, the 3, and the 5. The problem is complete.